Hi aligners, just in case you don't have your kit and you're already up to lab number 5, projectile motion stuff, we're going to do the ball in the cup lab and actually give you some data for that just in case you didn't get your kit. So here's the apparatus that I have, and that is the ramp clamp to the side of the table, and I put a plumb bob straight down so that I know where straight below where it starts turning into free fall. I want you to notice some things. If you read the book, you know that you're shooting it off horizontally, and there's something magical about the horizontal velocity. Yes, that's right, ladies and gentlemen, gravity does not affect it, and if we ignore air, that means Vx is a constant. So all I have to do is give you the data of measuring from here to the floor and give you that vertical distance, vertical y, delta y, and from that, and remembering the reaction time lab, you should be able to figure out the time in the air. No stopwatch, just find the time in the air by using an equation and that distance and knowing what planet you're on. Meanwhile, if I tell you where the ball ends up landing, how far away from the plumb bob the ball lands, I'm going to give you x. So all I'm going to do is give you x and y, and from that you're going to figure out the velocity coming off the ramp. That's part 1. Then we're going to take this ramp and put it somewhere different and have you do it over again, but this time now you know the velocity coming off the ramp, because that shouldn't change. And then you can solve for the x distance away from the bottom of the ramp and predict where to put a ball in a cup. That'd be cool. So let me just give you the measurements for x and y after I drop this ball about 20 times down. I put some carbon paper on the floor. What I'm going to do is get a cluster for you to measure where the, I don't know, average or median of all these balls going down the ramp. And they're going to land there. Okay folks, now I've taken some data. First thing I want you to do is see the height that the ball fell from. So that ball, look at the bottom of the ball. It started in free fall at what distance? Okay, that's 60, 70 something, okay? So read that distance, the bottom of the ball, that's the height it fell from. Find time from that. Meanwhile, this is the cluster that showed up. So you make the call, folks. What are you gonna say is kind of the mean or average? Where sideways did it land? How far sideways did it land? You guys make that call. Use that to find the velocity of the ball coming off the ramp. That's part 1. All right, folks. Now we got it at a new height. And that new height is, you make the call. Think about where the bottom of the ball would be and read that. It's a meter plus how much more? So 1 point, what do you think? Okay, did it make it to the 1.7 meter mark? Maybe you can read to the centimeters on that one. Maybe a millimeter. All right, now using that new height, predict where the ball is going to land on the floor. And if you actually could have done this lab, you're going to put a cup there and catch it, but alas, no kit. All right. Did you find delta x, how far away the cup should land, because you know the horizontal velocity, and now you know the new time due to the new height that we just measured? Let's have Mark, my friend, actually give it a try. Go. Oh! Here, do it again. I gotta zoom in on the thing. Ready? Let's try it. Go ahead. Oh, rim shot. Here, one more time. Looks like I'm right on. There you go.